Hi, it's Mr. Anderson, and welcome to Biology Essentials video number 25. This is on mechanisms of timing and control. And I'm going to talk about timing and control in plants, and animals, and even in bacteria. But I want to start by talking about something that plagues you if you ever travel, and that is called jet lag. And the reason jet lag's nasty is that you get used to a specific time. You set up what's called a circadian rhythm according to the amount of light that you get, what's the time of the day, and when you fly somewhere else, like this is across the international dateline, everything is kind of out of whack, and it takes your body a little while to accommodate for that, but we can, because we can set up a new circadian rhythm.
Good luck,
everybody! So in this podcast, I'm going to talk about physiological events, and that's going to be events that occur within a specific organism that allow us to do timing or control. And so, first I'll start with plants. And two big things that you should understand about plants are phototropism, that's how we go towards or away from light, and then photoperiodism, how do plants respond to changing amounts of light throughout the seasons. Next, I'm going to talk about animals and the importance of circadian rhythms, but we'd also find circadian rhythms in a fungus or in a plant as well. They're all tied to the time of the day. And then finally, I'm going to talk about timing and control in bacteria. And they use something called quorum sensing. A quorum is when you have a group of people together vote. And so bacteria will talk, they can communicate between bacteria of the same species and even between interspecies. And that's pretty crazy kind of stuff. So let's get started. Let's start by talking about phototropism. Phototropism is going to be growth towards light. We call that positive phototropism. So if the plant were to grow, you can see it. Light's over here, it's growing towards it. And not only is the stem growing towards it, but you can see that all the leaves are oriented so they can pick up the maximum amount of light. Negative phototropism would be growing in the other direction. And so immediately when you plant a seed, the roots are going to show negative phototropism. They're actually going to grow down into the dirt, away from that. And then we have gravitropism as well. Gravitropism is the response to gravity.
I know, isn't it right here around here?
How does a plant do that? How does it doesn't have muscles, doesn't have nerves. How does it grow towards the light? Or how does it grow away from the light? Well, they use a plant hormone called auxin to do that. Auxin is a series of plant hormones. Plant hormones, or hormones in general, just are chemicals that move around an organism and have a specific effect. And so auxin, what auxin does is it causes cells to lengthen. What it really does is it loosens up the cell wall. And so when you loosen up the cell wall, as water flows into the plant, it actually makes it get larger. And so let's say, for example, that I put the light or the sun over on this side, and that this represents a stem of a plant. And I know this is kind of diagrammatic, but let's say this is the stem of a plant, so it could be the stem of this plant right here. And let's say I put the sun over on this side. Let's give it a little happier. So the sun is over here. What auxin does is auxin will move inside the plant. Auxin will always move away from the light in positive phototropism. So it's going to move away from the light in this direction. Now, what does that do to the cells? It causes the cells to get larger. And so let me kind of clear this out of the way.
I don't have me a wolf. Still, not allowed.
So what happens to the cells where the auxin is? Well, the cells where the auxin is are going to get longer. And it's kind of a continuum. These ones not as long. These ones aren't going to change at all. I couldn't quite get the animation right, but what is that really going to do? Well, instead of making it just taller on that side, since all these cells are connected, it's going to cause this stem to actually grow towards the light. In other words, since these are all attached here, the whole thing is going to move in this direction. It's going to move towards the sun. And so you can see that. Now if I were to clear this all off, and let's say I put the sun on the other side, so the sun is over on this side, now the auxin would move in this direction, and then the stem is going to bend back like that. And so what that allows plants to do is it's a physiological response to changes in the amount of light. They can grow towards or away from the light. And they do that using auxin.
Right here.
Photoperiodism has photo
First
in it
we
as
have
well,
3
so that means
poles,
light.
you're 1
But what they're
part.
sensing is the
So
amount of
you're
light
and you're taking over a while.
throughout the
Just
day. So timing
this
it
is
during the day.
cool.
And
What
we
is it
think that
here?
plants use something called a
No,
phytochrome.
absolutely
Phytochrome
not.
is going to be a
Never,
protein that's found
ever.
inside
That's
plants.
absolutely
And when
emergency.
it absorbs light, it will change its conformation.
I'm so
In other
relieved
words,
nothing
it
happens.
usually
Nothing
has this
happens.
red
That's
phytochrome
all over
conformation,
and
but when it
news.
absorbs light, it'll switch to
No
a far
biggie.
red phytochrome. So
Everyone
it's actually going to
Boys, we don't have
change
to be
its
all over.
shape.
And
And by the amount of phytochromes that have changed their shape, they can tell what time of the day it is.
I have her
Now, why would you want to know what time of the day it is or how much light there is in a day? Well, that tells you what season it is, and that's super important. We'll talk more about that in the next podcast. It determines if you survive or not. And so what we could do is we could classify plants and the time that they flower to the length of the day. And more importantly, it's actually the length of the night. And so poinsettias will actually flower around Christmas, and they flower when the days are really, really short or the nights are really, really long. And they're sensing that using these phytochromes. Or Arabidopsis is a plant that we use a lot of the time in studies in biology. It's actually going to require a long day. Lettuce is an example of that. So it needs a really long day or a really short night to flower. Or a dandelion doesn't care. Dandelions are going to flower all the time. So it's independent of the amount of light that they get. And so this allows plants to kind of respond to their physiologically respond to their environment. Now, plants will actually move their leaves during the day, and that's called a circadian rhythm. But we have a circadian rhythm as well. In other words, as long as the light is out, our light is going to go through the eye, and we're going to sense that in something called the pineal gland. It's a small gland inside your brain that looks kind of like a pine cone. But what it's going to do is it's going to release a chemical into your brain called melatonin. Melatonin is going to set our clock or our internal clock. And so if you look through, this is I got this from Wikipedia. It's pretty cool. So in the morning, we will have a high blood pressure rate, the sharp rise in blood pressure rate before we're getting out. We stop making melatonin in the morning. Bowel movements are likely at 8:30 in the morning. This is pretty funny. Best coordination looks like at about 2:30 in the afternoon. Start making melatonin at night. So what does this mean? We're set on a 24-hour schedule. And so our body, according to the amount of light, sets itself on a schedule. And so that's why jet lag is a problem. If we move somewhere else, we're already on a different schedule. And so now we have to wake up at this time or we have to wake up at that time. And so it's hard for us to do that. But again, we can set the amount of melatonin. It doesn't take us but a few days. And we can set a new circadian rhythm.
Lori, what's going on?
Quorum sensing in bacteria.
Hey, Lori, Lori.
Because what it really is a way that bacteria can communicate with other members of their species or even members of another species.
I don't
know,
so Lori,
but I'm
sure everyone knows.
I think history like this is 7 years old. Can talk and all right, Lori. Now leave her alone. I don't want yummy. You're for bacteria are going to give off what are called autoinducers. In other words, those are proteins that essentially just say,
British girl had her British boy.
And if you are one bacteria by itself, a lot of those are just going to
walking cycle.
However, if there are more bacteria,
I think
and they give off their autoinducers,
oh man, where's she going now?
The chances that one of those will bounce into another bacteria is going to be and if we even have more bacteria, there's more autoinducers. And
don't everyone's
more
here.
Bacteria are going to be
I'm afraid of. No, you don't.
So what does that mean? Bacteria can see how crowded it is. And if they're all by themselves, they're going to have one behavior. And if they're not, they're going to have a different behavior.
What is a competition?
And so it's a really complex way that bacteria can actually
Can you ever one more ever
and so what
at
they
all?
can do is they can start giving
absolutely not.
Other proteins.
Never ever have
so this one picks up this autoinducer. It says, hey, I'm crowded. It can send
other
proteins
nothing happened to you.
that are going to trigger a specific response. And so what do I mean by trigger a specific response? Well, for example, it could allow them to communicate and work together to solve a problem. It could increase their virulence. In other words, bacteria might grow to the point where there's so many of them, now it's time to actually attack. where they could form biofilms,
Yes,
or
it
they could
is.
move
Your
really,
job
really
is
quickly.
props.
And so all quorum sensing is a
Fake,
way to
matching, dancing,
communicate
books.
bacteria to bacteria to say,
No
hey,
one's
this is how
ever
crowded
mind
it is.
what is a
And
real
they can have different
hatch mean
behaviors
alone.
depending on that.
Not
And so it
good.
gives them real complex
Hard.
behaviors.
I'm sorry,
Behaviors that
kids.
we
Whenever
never
our
even
information
envisioned
has
years
me
ago.
no kids.
And so that's
Boring,
how
I just
plants,
feel over.
animals, and bacteria
Never
respond to the timing
I
and
Why
they
am
can
I?
sense their environment.
What is
And I
it?
hope that's helpful.